Welcome back to Nomad Boat Building, folks. I'm Mark Rudin, and we're building the International 2.4 meter. Now, today we're going to focus on lofting, or as I like to call it, juggling spaghetti. The essence to understanding lofting is really just being able to visualize the various sections through a boat. And to illustrate that, my friend Mark will give you an example.
We have the station lines, which show you the cross sections of the boat, and that's just like the way your typical loaf of bread is sliced. That way. You bust those open, you look at the face of your sandwich, that's the same thing as the stations on a boat. Now, water lines are like the submarine sandwich, where you get your loaf and you slice it down the side, you open her up, you dump your stuff in the middle. That's what water lines are. Now, buttock lines are like your chili dog. So you get your bun, and you slice it up the middle instead, you pop it open, you drop your dog in there, you dump your chili in there. That's a buttock line. And then lastly, we have what we call diagonals. And there's no sandwich equivalent for diagonals. Diagonals are what you get if you were to take the boat, and from the center line out, you just draw some diagonal lines.
So, today we're not going to get into the nuts and bolts of lofting. If you're interested in that, try checking out the first few episodes of my Bushi-Dori series where I walk you through laying down some lines. What we're going to do today is just look at a few aspects of lofting as related to this project. So we're going to look at a stem expansion. We're going to look at juggling some water lines and playing around with battens a little bit. Now, the trickiest thing I want to discuss is bevel boards. Now, these are bevel boards, but this is not what I'm talking about. We use these for finding angles or laying down angles that we want to describe onto a piece of wood. We're going to be making a mylar bevel board for the purposes of something that we call mold reductions. Now, mold reductions are where we take the full-size mold as described to the outside of the planking, and we reduce the thickness of the planking, and sometimes we also reduce the thickness of frames underneath. And there's a particular technique that we use to do that accurately, and I'm going to try and describe that to you. Now, this is a really hard thing to visualize, and it's an even harder thing to explain, but I think I came up with a way that makes it a little bit less murky, and hopefully you'll pick up what I'm laying down. Okay, without further ado, let's go get to work. I'm just working on my stem design right now. Got my stem profile right here. And I've decided I want to add a solid wood cut water just because I think it's a good way to finish off the ends of planking in general. Covers any end grain. This is going to have sort of a soft nose on it. And so I want something that's easy to shape. And also, whenever there's damage, it's just having something you can replace very easily makes so much sense. So what we need to do is do what you might call a stem expansion. And that really is trying to figure out what the cross section of the stem looks like. So to do that, you create some cross sections through the stem. And here you'll see got a few lines here. This line right there, that one there, that one there. Those are all center lines or cross sections through the stem. And so to figure out what that stem shape is, we take those lines and we project them out until they reach some other feature on the drawing that I can make use of. So in this case, I've used the shear line here to give me a reference in order to come up with the cross section. So don't think about these as just lines on the board. Think of these as a slice through the stem itself. So imagine we've taken a big, cleaver and gone chop, and we're laying that chop portion down flat and having a look at it. So where this line coming from the face of the stem crosses the shear line gives us a reference point. So if I take that and I project that out, imagine that we're taking this and laying it flat. So I take it out. I need to find out what the width of the stem is at that point. So it happens to land on a station line. I did that by design. I can follow this down to my plan view, and then I can pick up the width of my shear at that point and lay it off along this line. And then of course I do the same thing basically with the face of the stem. I've got that drawn out down on my plan view. And I connect the dots between those two. It's really as simple as that. I'll do a little demonstration here. So down here at the heel of the stem, I'll do another cross section through it. So if you take this square, and it's going to come right down to like the heel of the stem here, the cut water. So I'm going to draw a line that projects out. I'm just going to go boogity, boogity, boogity right out here. And it interacts with the shear line again. It actually also interacts with I've got a water line right here. Water line 200. Darken that a little bit for you. So that line I just drew out connects with the water line right there, and it connects with my shear line out there. So let's find those dimensions. So I need to create a right angle to those points so that I've got something to lay off these dimensions along. So just like so, right angle there, and we do another one up here. And fair warning, there's a good chance that this one may not land quite right. There's something going on with this drawing that I can't quite place my finger on just yet. I'll figure it out, but at the moment I'm just a little perplexed, and maybe I was just missing something earlier. It's been a while since I've had to do any lofting. Anyhow, so we need the width of the stem at this point. So what we do is we take this point and we project it down to our body plan. So I'm going to do that simply by using a little tick stick, and you really want to catch it right at the point that your line projects out from. Take that down there, and here it is over here. Turn my stick, pick up that width, and bring it back up here. And I happen to have, my stem has got a taper to it, which is why I'm doing it this way. If you didn't have a tapered face to the stem, it would just be a consistent width. So there's one of my points to connect right there. So let's look at the water line now. I need to know the distance of my water line to this point. So if I pick that up, and I'm just using this as a common reference, bring it all the way down, and then I find, here's my water line over here. So I find that point, and then I turn my stick the other way, and working from my center line, I pick up the width of that to there. We bring it back up, and I turn it back around, carry it over here to this little perpendicular I created, and there's one of my points. Now I'm going to do the same thing at the shear. Now what might happen is, because I'm going to have 3 points now, it's going to describe something other than a straight line, because of course the boat isn't made up of flat surfaces, it's made up of curved surfaces. And the more shape you have in your boat, the more reference points you want to grab in order to get a really accurate idea as to what's happening down here. So over here, there's my point on the shear. Pick that up, and then I'll just use this station line as a reference. We carry that down, and I come over here to where my shear line is in my plan view. I align my reference line, I align my shear line tick to there, and that's going to give me a point. I turn this 90 degrees, I make a tick at my center line, and then I make a tick at where that shear line width is. Come back up here, rotate it back around, pick up that point, and now I've got 3 reference points. I'll pop nails in there just to make it easier to see. There's reference point 1. There's reference point 2. That's where the water line, where this section crosses a water line. And then this is the stem face. Okay, if I put a straight edge on there, it's very unlikely to be straight. And see, I'm not at all surprised at that. It should be a curve. Let me just grab a batten. I just got a bundle batten here. We'll use that. That's fine. It could just be a straight stick too, but as long as it's flexible enough. So if I take that bundle batten now and I wrap it around, it's such a slight amount. I mean, you could get away with I could have gotten away with a straight line between there and there, but it's not a terrible thing to just to get a broader idea as to what's going on here. If nothing else, it just sort of informs me what's going on when I'm building the boat as to what shapes to expect. So if I just draw that line in, that gives me a nice little cross section. Always pull your nails out, by the way. It's so easy to step on those if you don't do that. Okay, now if you take a closer look here, this will be my center line through the stem, and my cut water, if I make it an inch deep, will basically be this part right here. All right, and now if I lay off what my planking is going to be, so this will represent my planking. Lay that along that line I created, and I draw that in, and then this represents what my planking is going to be. And so now I need to figure out what I want for a stem. So if I were to have an inch deep stem, I could use my ruler here, draw that in, you know, and then for instance this, if I wanted an inch deep stem, I might just do exactly that. That would represent my stem right there. So divide those up a little bit, darken them a little for the sake of the camera. Of course, this is just 1/2. It gets mirrored. But anyway, so that would be my stem section. And that's the basics of how to do a stem expansion. It's pretty straightforward. So when I go to set up to do to build the boat, what I'll probably want to do is I'll draw in what the stem would be. So I would, you know, draw another line an inch back here, for instance, and then I would design something that would support that stem as I'm building. So I'd have to come up with, I don't know, something that's like a station mold, but the stem fastens to it, which is typical. Some people might just make a stick that projects down and fastens to the strong back, or you might make something that's you know, a little fancier. It really depends on how you like building. So this kind of technique is really useful for any kind of situation where you need to figure out what the shape of the boat is at any point. So if I decided I wanted to create a bulkhead, you know, here, I can do that by drawing a line and finding all those reference points. Or if I needed to do cant frames, look at Scandinavian boats, you see cant frames in like a fairing. If I wanted to loft that out, I could say I want a cant frame somewhere in here, you know. I could draw this line. I'll just drop my batten here on it. Okay, draw a line through there. So we'll think, well, what's it going to look like through here? Well, now I've got different things I can pick up. I've got my width of my keel that I can project off of that line. I've got a water line width I can project to figure out how wide it is right there. I've got a station line right here, so I can go to my stations and I can find out how wide it is right at that point. I got my shear line. I can find out how wide it is at the shear at that point. And if I had other lines on here, for instance, if I had buttock lines on here, wherever those buttock lines pass through this, I could pick up a point and figure out how wide it is at that buttock line. Even if there were diagonals drawn on here, I could use those as well. So understanding how to do these expansions is extremely helpful in lofting, and it's kind of almost the whole basis of lofting is being able to figure out stuff like that. All right, it's time to create a bevel board for our project, and bevel board is kind of a hard thing to describe. So what we have here is basically a really big protractor. We are going to be creating basically a template that will help us to figure out what the angles are between our individual stations. That will tell us also how thick the planking will be at any given point between two stations. It's a bit hard to describe here, but what I'm going to be doing is laying off the spacing of our stations from the fulcrum of our protractor here. So I need to know what the angles look like at that distance. And let me see if I can explain it this way. So if we look at our model here, if we look along the backboard, along our center line here, there's no angle between one station to the next. It's one straight flat line. It's a zero angle. However, if you look over here where the planking lies, there's an angle between one station and the next station. And obviously it's because the stations are a different width. We need to know what those angles are. And we also need to know how thick the planking is at those angles, because the greater the angle, the more relative thickness that planking is going to have relative to a perpendicular line coming off the center line. And this little device will tell us how to do that. So the way I'm going to use this is I am just going to lay off a line with my station spacing, which is 300 millimeters. Do another one up here. We're just going to lightly connect the dots. There we go. Okay, now I need a piece of mylar. It doesn't need to be very wide. A few inches wide is plenty. Let's grab some tape and we'll just tape the mylar down along our station spacing here. I'm just putting the edge of this mylar right on the spacing. Okay, and then we'll just pop a nail right here in the center point. Then we just take a marker here, and all I'm going to be doing is following these lines and marking off the individual degrees. And if you notice my wooden bevel board, it's basically made exactly the same way. I've just sort of picked an arbitrary spot on the master bevel board here. Now I like to mark off my 5-degree increments with a different color just because it makes it way faster and easier to see what's going on. And if you tend to be working on boats that consistently fall within a certain couple inches of station spacing, say 24 inches, 18 inches, something like that, you could set up your master bevel board, like your permanent wooden one, at one of those spacings so that you can work right from it all the time and save yourself a little bit of trouble. However, having it on clear mylar like this is really useful in the process of doing what we call plank reductions. Now, a lot of the time when you do mold reductions like this, on very long skinny boats like canoes and kayaks and things, you can probably just get away with taking the plank thickness and just reducing that from the molds consistently across the board, because the difference in angle on a very linear hull like that is very, very slight, and even though you might not be 100% adhering to the lines, by the time you're done, it's close enough. But just for the sake of education, I thought I would go through this process anyway. Now, as it looks like we will probably be using 1/4 inch planking, I'm just going to lay off my 1/4 inch mark. So right here, I measure off a 1/4 inch from this edge where the station line is. Draw that in. So what that's showing us is down here where the angle is 90 degrees, the 1/4 inch is just a 1/4 inch. However, if you follow the angle of these lines, by the time we get up here to where it's like 30 degrees or something like that, 1/4 inch is now 3/8 of an inch by the time you get up to, what is this, 5, 10, 15, 20, 25, 30, 35, 40. So here at 45 degrees, we've grown by 50%. So that's a fair bit. And you can imagine if you're using much heavier planking, it's that much again. Okay, so that's what we would call a bevel board. And I'll just mark my station spacing here is 300 millimeters, 0.4 meter. So I don't confuse it with any other ones lying around the shop. Not that there are any at the moment, but down the road, I'm going to be digging through my pile of plans and things, and I'm going to find this bevel board. And if I know what it came from, I can make use of it. All right, the way this works, we're going to pretend that these are 2 stations. We'll just call this station number 1, and we're going to call this station number 2 over here. So right now, station 1 and 2 are parallel. So this boat is flat-sided at the moment. However, that's not the way our boat is actually shaped. Our boat is actually shaped as station number 2 being a little farther away from station 1, because, of course, the boat has got shape. It's generally, if you're looking straight down on it, it's triangular. Our stations are this far apart. Now here's our planking going from one station to the next. The angle of the planking relative to these two stations right now is this, which is like 5, 10, 14 degrees. And so at 14 degrees, the thickness of our planking relative to the station is, I don't know, if this was 3/4 of an inch thick going this way, it's now going across this line. Relative to this distance, this is now maybe an extra, or maybe almost an extra 1/8 of an inch wide. So that's important for us to know. If we want to take this mold as it's drawn, which is here at the outside of the planking, and reduce it by the planking thickness, we need to know exactly how much that is. And that angle is important. That angle is going to affect how wide that planking is at that point. Let's look at it more like this way. So if we flip this down, now there's our station, still sitting at the same location. And here's our next station, and it's sitting back here. So this is relative to this line, this is relative to that line. So if we were, just imagine we've changed our view from looking at it from above to looking at it from one end or the other end, whichever. Okay, this little guy that we've made up, basically, if we align it with one station, and we follow it across here, this will show us how many degrees it is between this one and that one, just by counting. So we get our 5, our 10, there's our 14 degrees between these two. It's really as simple as that. So this little guy that we've created here is basically a simple tool to figure out what the difference is between where this station is sitting and where this station is sitting relative to sort of a common plane, and it allows us to do it in a two-dimensional drawing. So when I was first shown this, I really did not understand it at all, and it's taken me quite a long time before the visualization has finally become clear. I thought I'd quickly show you how we use this bevel board. So I've got the aft station lines here, and it's pretty simple. You pick two stations, and in this case we're going to go from station 0 to station 1, and I simply line up first line here on the station, and I try and go square to the face of the station, and I just basically draw a line across to where it crosses the next station, and then I look at what angle do we land at, and in this case we landed at 12 degrees. So I just mark that off there, and then basically I take this guy, swing it around so that my 12-degree plank thickness is showing up here. Just mark it off on that line. That right there is my plank reduction. Going from station 1 to station 2, I just simply line up my first mark here, and I try and go, you want to go square to this station line, to the contour of the station, and I just go straight across, look at where I land here, and I land at basically roughly 11.5 degrees, pretty close to 11, so right 11 degrees there. And then for my plank reduction, it's this much right here, so I can swing this around, put my plank thickness on my station line, and then draw where it crosses that line. And so that distance right there is how much I need to reduce this mold at that point in order to allow for my plank thickness. So I basically do that through the whole thing. And so long as you've made this bevel board match the station spacing, that will work. And now there's a little bit of an error here in that if I technically, you know, it's 11 degrees from station 1 to station 2. It's maybe 10 degrees from station 2 to station 3 right here. A little more than 10, like 10.5. Technically, station 2 here would be the mean between whatever this is and that is. It's so close in this, it's not really worth messing around with. And jumping over station X, because it is not an even station spacing. There we got 10. Both these guys are 10. that off. Mark that off. And that's really all there is to it. Of course, you still got to cut these guys. So here, remember, I'm going square. I'm not following one line all the way through. I'm going square to the face of the contour. So here I get nominally 8 degrees. Jump over here and I get 4 degrees. Find my 8. And you got to remember to orient this to match these lines match those lines that you are crossing. It's this dimension here that we need, not this one. That's the same. This is the one that changes, following those angles. That's the really important part. And that's plank reductions in a nutshell. Stuff like down here, that's going to be a little more problematic for sure. I get a difference of 5, 10, 15, 20 degrees, for instance, between these guys. I'm not even sure what to do about that. It's such a weird contour. Luckily, there's not much difference in plank thickness, even at 20 degrees, because we're working with such light planking. So I'll work my way around the whole drawing, and I'll take, you know, I kind of, like through here, it looks pretty even. I didn't need to really do the second line. I probably would just take it down to where there's a noticeable change. I'll sort of radiate out, going maybe every 6 or 8 inches or something like that, and that's plenty. After that, I got to get a Mylar, lay it on here, and mark off all these points and connect the dots with battens. So I'm trying to figure out what's going on with my water lines here, and what's kind of tricky is I've got these shapes that go from these strong U shapes down to these pointed shapes. And so I'm trying to figure out what these water lines look like in these areas. So I've laid out this one line. If I just follow the dots, it just, you know, sweeps in fine. But I know that's not right because the one ahead of it takes this like sharp, soft turn as it comes into the center line. And so this one needs to do something similar. So I just thought I'd show you what happens if I take a very flexible batten here instead of a stiff one, and I bend it down here. It touches these lines fine, but maybe you can see here how it flares out a little bit. Now, however, if I start pulling on that and putting some more shape into it here, so it mimics the sort of rounded curves that I'm going to be getting in this area, you'll see how this guy flattens out, and at some point it actually comes into alignment with the section behind it. Go overboard, it gets a hollow in there, and so right about there, it feels like it starts to land where I want it to. I imagined I could get a little more shape into this if I had another little control point. So if I stop there and I just quickly sketch my line through, give myself another point to work around, I think I can get this into a stronger shape. I gotta keep it from back bending. So now if I do this, and that looks about right. Now if I draw that in, oh boy, draw this in here. Actually, need to put a nail on the back side of this. So the one problem with working with very flexible battens is you need to support them all over the place just to be able to draw against them. So just put my straight edge behind it just to help from bending anywhere. And there we go. I'm not sure that line is 100% perfect. However, it's a better looking line that's much more homogeneous with the one in front of it. So working with just some dividers off the profile drawing and picking up where some buttock lines landed with reference to the water lines, I was able to sort of add just one more point here along this load water line. It made a huge difference. So now that this line that I'm going to get now looks like a whole lot closer to what the other ones look like, so that makes me quite happy. I think I might even, I'll probably double check my my -100 water line here, and I think I'll probably try and do another my next couple water lines as well. And then just notice here that I had to use a really flexible batten to get this little sharp hook at the end here. I could even hook that a little bit harder, but I don't want to break my batten. But anyhow, and then I've used slightly stiffer batten in behind it just to support that, so that I can draw this line more accurately. There we go. That looks much, much better. Things look still a little different than this 50 water line, but that's because I was using a French curve to try and mark it in there. I mean, ultimately, it's going to come down to a fairing process to get all this sort of area looking right in the final project. But at least my lines are looking a bit better, and I'm feeling more confident about how I'm going to be doing this area. And a lot of the work I'm doing in here is to support figuring out exactly what happens with the stem, or in this case, it's becoming the keel, the forefoot area. A little follow-up here. So I just scaled off where my buttock line lands along my -100 water line, and you know, I kind of eyeballed where it looked like that fared in, and this landed smack dab on the money when I step it off. So I got that right. To quickly illustrate how I'm getting that information, right here I've got my water line -100 that I was just trying to figure out. That's right here. And then this is my buttock line 50. That would be buttock line 100. So if I need to find a reference point, so in this case I'll use where the water line -100 crosses station 11. So I pick that off, and then I pick up the distance along that water line to where it crosses that buttock line 50. So that's the dimension that I'm picking up. And then down here, I basically got my water line 50 drawn onto the board here, because don't forget we've reoriented ourselves 90 degrees. So now I just take that dimension and I just walk it off along that buttock line, and then this is, you know, once I've stepped it off, this is where the water line should cross it, and that's exactly what it does. So that's perfect. If I had the buttock lines drawn onto the profile drawing here, I would simply drop that line down from where it crosses the water line over here. I'd have this swoopy line up on my profile drawing. I would just find that intersection and drop it down here and mark it off here, and that would give me that information. So I'm kind of doing the same thing. I'm being lazy by not drawing buttock lines all over this lofting at the moment. I'm just trying to avoid putting more time into the lofting than I absolutely have to. Okay, that's all for today, folks. Now, if you enjoyed these videos, you'd like to help me make more, please consider joining me over on Patreon. There's a link down in the description. But of course, you can subscribe and like and all that good stuff. Now, I've got a hankering for a spaghetti sandwich, so I will see you later.